In the lesson last class, we talked about sequences and series, and in every case, what we had was we were trying to write a rule for how to find a certain term in a sequence. And the way we did that was by figuring out, well, the term was dependent upon its location in the sequence. And when we have a situation like that, where the term depends on the rule depends on the term's location, we always call that an explicit rule. So the A sub n's, all the A sub n rules that we found last time were explicit rules because each term depended on where it was in the sequence. Okay, what we're going to talk about today are some sequences where this is not the case, and what we see is going to happen, like let's take this sequence right here, and what we can see is that if I add 2 here I get 4. If I add 4 here I get 8. If I add 8 here I get 16. And so what we can see is that if I look at each term, if I look at 2 and double it, I get 4. If I double 4, I get 8. If I double 8, I get 16. So when we have a situation like this where each term depends on the term before it, we call this a recursive rule. That's what a recursive rule is. Okay, and we always have two conditions. We have to have an initial condition. So A sub 1 we call the first term. We have to know what the first term is. Why do we have to know that? We have to be given that because there's no term before, there's no previous term before the first one. So we have to be told what the first term is. All right, and then the recursive formula that relates each term after the first term to the term that came before it. So to the previous term, the one that came just before it, and what we're going to call that one is A sub n minus 1. Okay, so if we're looking at the third term, A sub 3, and we want to know how we got it, we have to see what we did to the second term, A sub 2, which would be A sub 3 minus 1. Okay, so if we look back up here at this sequence, let me erase all this. If we look at this sequence that we have here, what we got to do is we have to write our initial condition, our first term equals 2, and then every term after the first one, A sub n equals 2 times the previous one, and the previous term is always labeled A sub n minus 1. Okay, I think you're probably going to like recursive rules better than you liked explicit rules, but we'll see. All right, so let's write a recursive rule for each sequence. So remember, what we got to do this time is not see what the relationship is between the term and its place in the sequence, but rather the relationship between the term and the term that came just before it. Okay, so let's see what's going on here. From 3 to 5, I got to add 2. From 5 to 7, I got to add 2. I got to add 2. So it looks like I'm adding 2 every time. So I got to write down, remember, my first term is 3, and after that, my A sub n is 2 plus A sub n minus 1. All right, so what's happening here? My first term is 19, and what's happening each time? I'm subtracting 4, right? 19 minus 4 is 15. 15 minus 4 is 11, so A sub n is A sub n minus 1 minus 4. All right, why don't you pause the video and see if you can come up with the recursive rule for number 16. All right, don't forget, we have to define A sub 1. A sub 1 is 5. What's happening every time here? It looks like I'm multiplying the previous term by 5, right? So A sub n is going to be 5 times A sub n minus 1. All right, that's how we get a recursive rule. All right, let's look at this Fibonacci sequence here. We've got 1, 1, 2, 3, 5, 8. So let's see if we can figure out a recursive rule for this. In this case, I actually have to have two initial conditions. A sub 1 is 1 and a sub 2 equals 2. And then, so let's see, how do I get, here's a sub 3, a sub 4, and so forth. So what do I do to get the third term? Well, if I take a sub 1 and a sub 2 and add them, I get a sub 3. What if I add a sub 2 and a sub 3? I get a sub 4. So what we're going to do here is we're actually taking the two previous terms. So if I look at the third term, I add the two previous terms to get it. Okay, if I look at the fourth term, a sub 4 equals 3, and that equals 1 plus 2, which is let's see, the 1 is a sub 2, and the 2 is a sub 3. So my recursive rule is going to be that I'm going to take the two previous terms, so a sub n minus 1 plus a sub n minus 2, and I'm going to add those together to get the next term. Okay, and the difference in the recursive rule and the explicit rule, I can't just say to you at this point, okay, I've got this Fibonacci sequence here, tell me what the 30th term is. Remember, we could do that before in last lesson. I could just plug in 30 for n, but it doesn't work that way with recursive rules. You have to find each term before the one you're looking for, or you won't be able to find it. Okay, let's look at these and see if we can decide whether the formula is explicit or recursive. Then find the first 5 terms. Okay, number 18, well, I can see that's explicit. Why do I know? Because there's no previous term. There's no a sub n minus 1. So this is definitely explicit. And how do I find the first 5 terms? Well, a sub 1 equals 3 times 1 plus 2 equals 5. A sub 2 equals 3 times 2 plus 2, which is 8. A sub 3 equals 3 times 3 plus 2, which is 11. A sub 4 equals 3 times 4 plus 2, which is 14. And a sub 5 equals 3 times 5 plus 2, which is 17. Now, let me ask you this. Could I write a recursive rule for this one if I wanted to? What's happening to each successive term? If I go from 5 to 8 to 11 to 14 to 17, each term, each time I go up, I'm adding 3 to the previous term. So I could write a recursive rule for this, couldn't I? A sub n would be a sub n minus 1 plus 3, and of course I have to say for n greater than 1, because of course I have to be given the first term in a recursive rule. All right, number 19, definitely recursive because I see here I've got a previous term, a sub n minus 1. All right, so if the first term is 4, the second term is a sub n minus 1 is the previous term, so that's going to be 4 in this case, and I got to add 7, so that's 11. A sub 3 is going to be the previous term, which is 11, plus 7, which is 18. A sub 4 is going to be the previous term, which is 18, plus 7, which is 25. And a sub 5 is going to be the previous term, which is 25, plus 7. So I got 32. All right. 21, maybe 21 and 22, this would be a good time for you to pause and see if you could do these by yourself. I'm going to change colors so I don't get myself messed up here. All right, a sub 1 is 2. Oh, we definitely know this is recursive because I have our previous term here. So this is recursive. I'll just put an R here. We know it's recursive. A sub 1 is 2. A sub 2 is 3 times the previous term. So 3 times 2 equals 6. A sub 3 is 3 times the previous term. So 3 times 6 equals 18. A sub 4 3 times the previous term, so 3 times 18, which is 54, and a sub 5 is 3 times the previous term, so 3 times 54, which is 162. All right, so that's really all there is to figuring out a recursive sequence. And finally, number 22, looks like we definitely have an explicit rule because there's no previous, no a sub n minus 1. So let's figure out what we got here. A sub 1, 6 times 1 squared minus 1, which is 5. A sub 2, 6 times 2 squared minus 1, which is 23. A sub 3 is 6 times 3 squared minus 1, which is 53. A sub 4, 6 times 4 squared minus 1, which is 95. 96 minus 1, 95. And a sub 5 equals 6 times 5 squared minus 1. So 6 times 25, that'd be 150 minus 1. So I got 149 there. So you guys should be able to, at this point, find any term in any sequence, whether I give it to you as a recursive rule or as an explicit rule. Oop. There's the bell. All right, so we got a challenge here. Write the recursive rule. So I'm definitely going to have an a sub n minus 1 in here somewhere. You're always going to have that if you're writing a recursive rule. And let's see what's happening. Let's see what's happening between all these terms, from the previous term to the next. Okay, so if I multiply the first term by 2, I get the second term. If I multiply the second term by 2, I do not get the third term. So, let's see, if I multiply the 2 previous terms together, so right here, if I multiply these two, I get 2. If I multiply these two, I get 4. If I multiply these two, I get 8. If I multiply these two, I get 32. So that indeed is what's going on. So I got to define my initial condition. A sub 1 is 1. And since I'm using the 2 previous terms, sorry, I got a little interruption there. So since we're using the 2 previous terms to find the term after, we're going to have to define our first 2 terms like we did above on the Fibonacci series. So a sub 1 is 1, a sub 2 is 2, and then I can get every term thereafter by multiplying the 2 previous terms together. So a sub n is a sub n minus 2 times a sub n minus 1, and then I can find any term I want to, but now remember, with the recursive rule, I have to find all the previous terms to get the next term, whereas with an explicit rule, I do not have to get the previous terms to find any term in the sequence. All right, so on the next page we have some application problems. I know you love those. And what we will do is look at these maybe as our warm-up next time in class. So after you finish this video, how about take a look at these problems, think about what you can do with them, and then we will talk about them next time.